So we're going to talk about solving basic exponential equations right now. And the simple idea here of how I'm going to go about solving them is I'm going to depend on the following fact. The following fact is, if you look at the graph of these exponential functions are 1 to 1. And so basically what that means is if a and b are different numbers, then b to the a, I can't say b to the a. If x and y are different numbers, then b to the x and b to the y are different numbers. So if b raised to 1 power equals b raised to another power, then the powers are equal. So here's what I mean by that. Suppose that 2 to the x equals 8. All right? Well, 8 is just 2 to the third. So that means that 2 to the x is 2 to the third. So that means that x equals 3, because if these exponential functions are equal to each other, that means the powers are the same. And just to demonstrate that over here, I'm going to graph it. And if I do y equals 8, and sure enough, they intersect when x is 3. And I can make this a little more complicated. I could say, suppose 2 to the 3x minus 1 equals 2 to the 5x plus 4. And actually, just to me, it doesn't matter what the base is here, but we'll just make it 3 and 3 just for a change. So the bases are the same. So that means that 3x minus 1 and 5x plus 4 have to equal each other. And now we're back in a previous chapter. So there's a bunch of different ways we could do this, but let's subtract 3x from both sides and subtract 4 from both sides. And that gives me negative 5 on the left and 2x on the right. So then I get negative 5 halves is x. That's negative 2.5. And let's just graph that over here, just to show you what's going on here. 3 to the 3x minus 1 equals y, and y equals 3 to the 5x plus 4. So hopefully the point they intersect is colored in. I'm going to zoom in. So the problem is these functions get small so quickly. Change this to 1. This to negative 1. Oh, you still can't see it. All right. 0.2. Negative 0.02. Oh, wow. Oh, okay, well, it's really small there. All right, so you're going to need like some zeros in there. Oh, I put them on the wrong side of the decimal point. And we'll just change this to 0. Oh, no, there we go. And now I did too much. Anyway, you get the point. Let's move on to something more useful. I could do something more complicated, like 7 to the x squared minus 5x plus, or let's say minus 6 equals 1. Because 1 is 7 to the 0. So this is the quadratic equation x squared minus 5x minus 6 equals 0. So we can actually solve this using the factoring trick. The key here thing to notice is that negative 6 is 1 times negative 6, and negative 5 is 1 plus negative 6. So I can rewrite this as x minus 6 times x plus 1 equals 0, and I get x is 6 or negative 1. So I'm going to delete this, and oh good, it reset my graph. So if I do oops. Yeah, so you can see right there. 6 and negative 1. A slightly more advanced version of this is, what if I gave you something like 4 to the x plus 3 equals 2. So 4 is not obviously a power of 2. Or sorry, 2 is not obviously a power of 4, but 4 is a power of 2. I could rewrite this as 2 to the second to the x plus 3 equals 2 to the first. And then that's 2 to the 2 times x plus 3 equals 2 to the first. And so then this just becomes 2 times x plus 3 is 1. So 2x plus 6 is 1, because you distribute the 2. 2x is negative 5, and whoa, negative 2.5 again. All right, that's weird. And, you know, last but not least, if I gave you something like 3 to the x equals 1/3 to the x. Well, that says 3 to the x equals 3 to the negative x, since 1/3 is reciprocal. And so then you get x equals negative x, so you get x is 0. That's. But what if instead I have a squared equals b to the negative second? This is a different sort of equation. Now the bases are different. Well, so if a squared is b squared, then that means that a squared is the same as 1 over b squared. Does that make sense? So if these things are the same square, then that means you take the square root of both sides and you get a is plus or minus 1 over b. And so then you get that a times b is plus or minus 1, which is a lot of things. Right, so for example, if you had a to the second equaled a to the negative second, then you get out of that that a is plus or minus 1 over a. So a squared is plus or minus 1. And in fact, though, since a has to be a real number, that means that a squared is just 1. And so a here would be 1, or it would be negative 1. In fact, since we know that a and b have to be positive here, we can't have a as negative 1 over b anyway. And so we could just get rid of that plus minus altogether. All right. So we're sort of limited in how we can solve these exponential equations right now. So I'm going to talk about an application of exponential functions, and then we're going to talk about how we can solve these things more effectively.